let's talk about fictitious forces. That means force that isn't really there. It's actually a different phenomenon, namely Newton's first law that's happening, but it appears to be a force. So sometimes when we encounter centrifugal forces, or what appear to be centrifugal forces, they're actually fictitious forces. So centrifugal means center fleeing, pushing away from the center, as opposed to centripetal, which means center seeking. So forces that attract, like a tension force or gravity force, are centripetal. They pull towards the center of circular motion. There are centrifugal forces in nature. The magnetic force could be one, when magnets repel. The electric force between two like charges could be a centrifugal force. Those charges repel one another. But what often happens is that there's a fictitious centrifugal force. And an example of that could be if you're riding a merry-go-round, which maybe you did when you were a kid on the playground. So imagine that you're on this merry-go-round, it's spinning around, and you're standing here on the edge. Now, if you've ever done this, you probably noticed that you had to hold on tight, or else it felt like you were going to be thrown off. So that feeling of apparently being thrown off the merry-go-round is this fictitious centrifugal force. And what's really going on is that there's not actually a force trying to push you off the merry-go-round. It's your inertia that's carrying you in a straight line path. So you want to continue moving in a straight line. The merry-go-round's moving in a circle, so you have to hold on. You need to apply a centripetal force using the friction between your feet and the platform, maybe by holding on to a pole or bar or something that's built into the merry-go-round. You need to apply a centripetal force so that you don't get thrown off. And that feeling of getting thrown off is this fictitious centrifugal force. So what's really happening when this thing is spinning is that your instantaneous velocity at that point is to the right. And by Newton's first law of motion, your natural tendency is to continue moving in straight line and constant velocity, unless there's some external force acting on you. And so that external force would be friction between your feet and the platform, or holding on to bars or something. But if you let go, or you're just not strong enough to hold on to the bars, you get thrown outward, except you're not actually getting thrown. It's not really a force that's throwing you. It's your inertia. It's your Newton's first law of motion, where you're just continuing to move in a straight line. So if you let go, where you're not strong enough to hold on, what happens is that you get thrown off that merry-go-round. But you're not being acted on by a centrifugal force. That's fictitious. It doesn't really exist. You're just continuing in you're continuing at your constant velocity in a straight line.